In this lesson, we're going to cover the Arista Tap Aggregation feature. This lesson will serve as an overview. We also have a lesson specific to tap aggregation configuration. You can find configuration details in Arista's most recent configuration guide. And because of the various use cases of this feature, you'll find a significant amount of information on the arista.com website, including a specific section dedicated to tap aggregation. Arista's tap aggregation solution falls under the umbrella of Arista's DANS feature set. DANS stands for Data Analyzer. In the industry, you may hear tap aggregation also referred to as a tools concentrator, a packet steering device, or a network packet broker. There has been a growing interest in tap aggregation as organizations try to gain more visibility for operations and security. The basic premise behind the tap aggregation feature is that we may have a need to capture or copy some or all of our data center traffic for the purposes of analysis by various tools. Those tools could be security-related, network performance monitoring tools, or application monitoring tools. It is not uncommon for folks to say that we need to see every packet in the entire data center to be analyzed by our tools. But the problem we often run into is that we don't have enough switching resources to mirror over all that data to the various tools that we may have. Or perhaps we can copy that data to another device, but often run into bandwidth contention issues because we're mirroring too many packets for the tool to handle. Arista's tap aggregation solves this problem for us. Arista's tap ag allows us to take a switch of specific models and lobotomize that switch so that it is no longer a normal networking device. It becomes a device that receives a copy of our packets for the sole purpose of getting those copies to our suite of tools that need to analyze those packets for either performance or security purposes. When I say lobotomize, what I mean is that these specific Arista switches, when running in tap aggregation mode, will no longer be switches that are moving around production packets. When running in tap aggregation mode, the switch is not sending BPDUs, nor is it running routing protocols. Instead, the switch is going to receive a copy of the production packets, and then it will steer those packets to the appropriate tool or set of tools. This comes in handy when you find yourself with more tools than you have mirror ports available on your production networking devices, or if you have a limited number of optical taps. As an example, let's place one of our lab switches into tap aggregation mode. First, before we do that, let's look at the interface status before we put the switch in tap ag. So in our lab here, if we issue the command show interface status, enter, we can see that we have several ports that are in either a connected state or a not connected state, depending on the cabling and the operational status. So now let's put the switch in tap aggregation mode. We type config, enter, tap space aggregation, enter, and in here we're going to use mode space exclusive, enter. And notice that we get a warning painted to the CLI that changing the modes will restart the forwarding agents and may affect available functionality. So if we get out of configuration mode using the end command and reissue our show interface status command, you'll notice that all of our ports are now in air disable mode. While in tap aggregation mode, you must define a port as either a tap port or a tool port. We'll dig into that more a bit later. I like to view the tap aggregation switch as a bucket. This bucket is receiving a copy of the production packets, and then it will send those packets to whichever tool needs to see them. And thanks to traffic steering, I can have one tool receive all the packets, or multiple tools receive all the packets. Or we could just have some tools receive a subset of the packets. The solution is very flexible to meet the varying needs of your deployments. The really cool part about running tap aggregation is that it only takes a single command to put the switch into tap aggregation mode. Another side note, there is the concept of running in hybrid mode on some of the switch models, so be sure to check the documentation about each platform's capabilities. Tap aggregation is one of those topics where it might take some time to figure out where it is best to place the device strategically in your network, but to actually configure it only takes a few minutes. There's only one command to put the switch into tap aggregation mode, and then only a few commands to steer the received packets out to the appropriate tools that you connect to your tap aggregation switch. It may help to use a picture as a reference. Near the top center, we have an Arista switch that's running in tap aggregation mode. And notice at the bottom, we have a series of production switches in the regular data center. We have two ways to get traffic to our tap aggregation device. We can use network taps, where we have optical taps that send our traffic over to a tap port of the Arista Tap Ag switch. Or from our production switches, we can use a mirror port to send traffic over to our tap aggregation switch. There are two roles that an interface can play when the switch is running in tap aggregation mode. There are tap ports and tool ports. In this picture, we have the tap ports identified as purple and the tool port identified in orange. The optical tap or mirror from other switches feed into what is known as tap ports. The tap ports only ever receive. They never send or transmit anything out to the network. The tool ports are where we connect our analysis tools. Tool ports only transmit. They never receive. So because our tap ports don't transmit and the tool ports don't receive, we often consider the tap aggregation switch as a device that can fly under the radar of change control. You have little risk, or significantly reduced risk, of harming the production network as you configure the tap aggregation switch. With the Arista's Tap Ag feature, there is no preconceived idea of which interfaces can run in tap mode or which can run in tool mode. Any interface can be placed into tap mode, and any interface can be placed into tool mode. That shows immense flexibility, how many of each port type that you have, which can be used in whichever way fits your deployment needs. You can have as many tap or tool ports as there are interfaces available on the switch. The key is to be mindful of not overrunning your interfaces with too much traffic. In other words, while the switch doesn't care if you have 10 tap interfaces and one tool interface, it's easy to see that such a configuration could overrun the single tool interface if it doesn't have enough bandwidth. So let's configure a few ports as tap and tool ports. We'll configure Ethernet 15 and 16 as tap ports, or receiving traffic from the network. To do that, we just type config to get into configuration mode, and then interface Ethernet 15, and simply switch port, mode, and tap. Enter. And then we'll do the same thing with 16. So interface Ethernet 16, switch port, mode, tap. Enter. And we can verify our configurations with the show run interface Ethernet 15 and show run interface Ethernet 16 commands. Now let's configure Ethernet 23 and 24 as tool ports. We'll take advantage of the option to configure multiple interfaces at once. So here I'll type interface Ethernet 23-24, enter, switch port, mode, and in this case, we're going to make it tool instead of tap, enter. And then we can verify our configurations with show run interface Ethernet 23 and show run interface Ethernet 24. After you configure a tap port and a tool port, you need to associate those interfaces to a group or a set of groups. The group option is how we steer traffic from an ingress tap interface to the egress tool interface or interfaces. Also, within the configuration of each tap port and tool port, you can filter the traffic by including or excluding certain VLANs. And for those shops that have strict rules about data that is captured on the network, Arista provides the concept of truncation. Truncation is the way to chop off or slice just the portions of the packets that we need to analyze for security or performance reasons. Some organizations are not allowed to capture the full packet, but are allowed to get the source and destination MAC address, source and destination IP, or the source and destination port numbers. For those scenarios, you can enable truncation and select the size in bytes. Another cool feature within tap aggregation is the concept of identity tagging. Some tools can understand tags, and this becomes helpful in the event that you're capturing from multiple locations within the data center. A useful example is a situation where your security team states that they want to see every packet from every switch that it may cross within the data center. This could mean that they see a packet as it ingresses the DMZ and then works its way into the regular, non-secured side of the corporate data center. In that case, it would be helpful if you could tag the packet to reflect which switch or which location in the network that the packet was captured at. With the identity tag feature, you can assign a tag, much like an additional VLAN tag, to each packet as it ingresses a particular interface. Then, if the security tool supports it, and many of them do, they can tell where the packet was found to have traversed the network. So if they are hunting down something suspicious or malicious, they could determine if that packet only made it into the DMZ, or if that packet not only got into the DMZ, but also found a path all the way through the DMZ and into the corporate side of the data center. The identity tag feature is part of the interface configuration of tap aggregation. I should also mention that there is a GUI for tap aggregation. It's referred to as the TAM, or the Tap Aggregation Manager. The GUI is enabled locally on the switch, and then you simply point a browser at the proper URI as documented in the Arista configuration guide. While I'm generally not a big fan of GUIs, in my opinion, this one does come in handy for two specific reasons. First, because you're associating tap ports to tool ports, to groups or a group, the GUI makes that very easy to visualize. Second, since this device is often purchased by the network team, but frequently managed day-to-day by other groups, namely the security team, having a GUI makes it easy for the security admins to make changes without having to know the Arista EOS CLI, and saves them from walking over to the network team to request changes. They can easily log into the GUI and via pull-down options properly pick their tap ports, their tool ports, the appropriate groups, and apply ACLs as part of the traffic steering configuration. The GUI also provides nice graphs to show interface utilization. To enable the Tap Aggregation GUI, or the Tap Aggregation Manager, we enable HTTPS within the Management API configuration mode. So here we type Management API space HTTP commands, enter, and then simply a no shut. Or, as in the case in my lab, my management interface is tied to the management VRF. So if we need to associate this to a VRF, we can simply declare that VRF with a VRF. In my case, my VRF definition is management, MGMT, enter, and then here type our no shut, enter. And if we were to exit out of configuration mode, we can issue the show run section management and see our management API HTTP commands with the no shut associated to them. And then we can point a browser at the tap ag switch and use standard authentication methods to gain access to the device via the GUI. Be sure to check out the tap ag guides, the transfer of information, and blog articles available on arista.com and Arista's EOS Central website.